Dear students, the banker algorithm sometimes referred to as the detection algorithm. Why? Because the banker algorithm can do two jobs for us. One job, deadlock avoidance. Second job, deadlock detection. Okay, that's why the banker algorithm sometimes referred to as the deadlock detection algorithm. Okay, the banker algorithm is a resource allocation and deadlock avoidance algorithm. Okay, remember, dear students, how if someone's thinking that how the banker algorithm will avoid the deadlock, because the banker algorithm will try to fairly allocate the resources, and by fair resource allocation they will try to avoid the deadlock. How they will avoid the deadlock? Because they will try to keep the system in the safe state. Okay, and it's developed by Isgar Dijkstra. Okay, it's developed by this scientist. And as I told you before, when you have multiple instances, you will use banker algorithm. And you know that each process must have what? A prior claim. When a process requests a resource, it may have to wait. How? Let's suppose if a process is requesting more instances than available amount of instances, then the process have to wait when the system is become able to provide them the required amount of instances. So it means that it will be not always possible for the system to allocate how much resource are required by the process. Sometimes the process will wait because the system will partially satisfy the request of the process. Okay, when a process gets all its resources, then of course they will execute the resource. They will use the resource, and once the process is going to be terminated, when they become finished, then it must return them in a finite amount of time. What return? They must return their resources to the operating system in a predefined amount of time, a well-known amount of time. Okay, so dear students, you have to remember these 4 lines. These are very much important lines because these lines will help you to understand the coming slides. The first thing was that when you have multiple instances, then we will use banker algorithm. When you have single instance, the system will not use this. The system will use a simple algorithm, which is a resource allocation graph. Okay, each and every process must have what? A prior claim for their maximum use. A process can wait, and when a process gets its all required amount of resources, it must utilize them, and after utilization it must return them in a finite amount of time. Okay, this is the data structure of banker algorithm. Okay, I'll explain these things in a multiple charts. Okay, right now I'm just going to explain this main headings. Later I will explain the rest of things. Okay, see, first I have in this data structure available, maximum, allocation, need. Dear students, available mean free resources. Available mean free resource. Okay, maximum mean the maximum demand of a process. How much maximum resources will be required by a process. As I told you before, that each and every process must declare their maximum use of the resources. Allocation mean assigned resources. Need mean more need resource. Like for example, not more, the suitable word will be here, that let's suppose if the process is required 5 and the system allocate them 2, then the 3 is the need amount of resource. Okay, So dear students, try to understand these four terminologies: available resources, maximum resources, allocation or allocated resources, and need resource. Okay. And here in this vector of m and n, where the n represent number of process and m is representing number of resources. And maximum allocation need will be n cross by m. N cross by m mean to the all processes, all resources can be allocated. N cross m. N cross m, where you got that n is mean processes and m is resources. Okay. What the other conditions? Wait for this. Okay. Okay, this is the safety algorithm. This algorithm will be used by the banker algorithm to keep the system in a safe state. But I will not explain this right now because during this example, I will try to explain that. Okay. So let's try to understand the banker algorithm with this example, and everyone should be very conscious, okay? Because banker algorithm is very much important from your examination perspective. So if you guys understand, though, there's possibility that you guys will win very good marks. Otherwise, you know, okay, and this algorithm is sometimes it can be very tough algorithm for most of the students. So that's why you have to be very conscious, okay? So example of banker algorithm. See, dears, right now in the system, I have 5 processes. It means the number of processes are how much? 5, which start from 0 to 5. You can see here 0 to 4, okay? Which is 0 represent 1, 2, 3, 4, and 5. It become what? How much? It become 5 processes, okay? I have 3 resource types. It means I have 3 resources. Different type of resources. And these resources are multi-instance resource. Resource A is consist of 10 instances. Resource B is consist of 5 instances. And resource C is consist of 3 instances. Okay. And this is the current snapshot at the time 0. This is the word, the current or the snapshot at a time 0. Let's try to understand what is here in this snapshot 0. But we will try to understand this with the help of a Microsoft Word file. Okay. Focus on my screen, dear students. I'm going to open the Word file. And here you can see the same table, okay? Okay, guys. Number of processes were how much? Faisal.
5, sir.
Okay, 5. Start from P0 to P5 to P4. Okay. Number of resources were how much? Equal to 3. Okay. They were what? They were resource A, resource B, and resource C. Okay. Number of instances. Number of instances per resources. Okay, let me make it a little larger. Okay, guys, so number of instance per resources where resource A
Was 10.
equal to 10 and B were equal to 5.
B was 5.
Very good, dears. And C were equal
C
to,
was
good.
7.
So let's write here P0, P1, P2, P3, and P4. Okay. So let me delete the last row. Okay. So allocation of resource A, allocation of resource B, and allocation of resource C. Allocation maximum demand for resource A instance, maximum demand for the resource B instance, and maximum demand for the resource C instance. Needed amount of resources from A, needed amount of instance from resource B, and needed amount of resources from instance from resource C. Okay, available instance of resource A, available instance of resource B, and available instance of resource C. It's very easy. Some just like, we have multiple instances, multiple resource, and each resources consist of multiple instances. That's why we have to write them for multiple time. Okay. Okay, dears. Now I have to write the allocated resources. I have to write what? The first diagram, which is allocate resource. You can see, dears. Okay, let me this side by side. Okay, guys. See, from the resource A, how much instances are assigned to P0? Zero amount of instances. To P1, how much instances are allocated from the resource A? 2 instances. To P2, how much instances are allocated from resource A? 3 instances. To process 3, 2 instances. To process 4, 0 instance. So they were the allocated instances from which resource? From the resource A, okay? And now let's come to the 5. To P0, how much instances are allocated? Okay, if you guys are thinking from where we will know how much is allocated, dear students, it's not our job to understand this, how much is allocated. It's the algorithm responsibility, okay? And whenever we will solve such type of examples, the snapshot will be already provided to us, that this is the system snapshot, which is holding this information, and find some values like need amount of value, and find that the system is safe state and the unsafe state. Okay, we will just try to find them. We will not try to find them how much is allocated, how much is maximum demand, because this will be give you by the example. Okay, so guys, the second resource, which is resource B, how many instance of resource B is allocated to P0? 1 instance. How much to P2? Yeah, P1, 0, 0, 1. And to P4, how much instances are allocated? 0 amount of instance. Okay, let's come to the C. 0 instance, 0 instance, 2 instance, 1 instance, and 2 instance. Okay, how much is demanding by the maximum? What was their maximum claim or their declaration? Dear students, it was 7 of the P1. The P1 was declared that I will need 7 instances of resource A. P1 declared or claimed that I will need 3 instances from the resource A. P2 claimed that I will need 9 instances of resource A, and so on. P2 P3 claim for 2, P4 claim for 4. And here P0 claim for 5 instance of resource B, P1 claim for 2, P2 claim for, sorry, P3 claim for 0, P, uh, yeah, P2 claim for 0, and P3 claim for 2. When we start from 0, so there will be some sort of most of the time confusion. Okay, so in the P4 claim for 3 instance. Okay. Okay, guys. If anyone is confused, so he can ask their question. I can stop for a few minutes. No problem. Is there any confusion? What I'm doing right now?
No, sir, no.
Okay, good. Let's
It's
continue.
clear.
Okay, the maximum claim of the processes against the resource C. Okay, so P0 claim for 3, P1 claim for 2, P2 claim for 2, P3 claim for 2, and P4 claim for 3. So these are what? These are the maximum claim of these resources. Now let's find the available resources that after this allocation, you can see after this allocation, how many amount are free with the system? How many amount are free with the system? Let's find them, dear students. And before that, if it will be good if I highlight these borders. Okay. Okay, guys, so these two things are already clear. Now I have to find out the maximum resources. So for this purpose, I need to go back to the slide. Okay, to the data structure of this algorithm, okay? Okay, guys, I'm going to find what? The need amount of resources. So for this purpose, there is a formula. When I want to find the number or the amount of resources, how much is further needed, I have to use this formula. Maximum minus allocation. Maximum of what? Maximum of I processes. N cross to J. J is allocated resources. Okay. So maximum cross I to J minus allocated cross I to J is equal to need amount of resources. Okay, based on this data structure, now I will find the required number of instances here, that how much more instances are required. Okay, let me clean this. Okay, so need amount of, I'm going to find need. Need mean what? Maximum minus allocation. Okay, so according to this rule, you know, dear students, that you have to minus the maximum was what? The maximum was 7. The P0, the P0 maximum need was, okay, let me process maximum and allocate it, and then need. Okay, P0, how much maximum demand? 7. 7 for resource A. How much was for the resource B? 5. How much was for the resource C? Okay, 3. Okay, but actually I was finding the available resources. Okay, no problem. So I will take a break here because break mean switch back to the find this available resources. Then I will come to the need resources. Okay. So I'm going to find what the available amount of resources. And this is very easy. Available is how much? At the A with the resource A, B, and C. Dear students, you have to add them. 0 plus 2 plus 3 plus 2 plus 0 is equal to what? 7. Okay. So for A, it's equal to how much was total instance of the resource A? 10. 10 minus how much? 10 minus 7 is equal to 3. So it means that with the A, I have 3 free instances. Okay. Okay, with the A, I have 3 instances. Let me write this here. What about the B? B equal to, total was how much? Total was 5. Minus how much? Minus this. 1 plus 0 plus 0 plus 1 is equal plus 0.
-2.
Yes, very good. It's 2. So equal to how much? Equal to 3. Okay, so 3 resources are available with the system. With the C, how much was total? 7. Now 0 plus 0 plus 2 plus 1 plus 2 is equal to 5. 5 minus 7 is equal to 7 minus 5 is equal to 2. So dear students, this is the free available resources with the system. If someone is thinking that when the system have this much free resources, why they are not completely satisfy the requests of any running process? Dear students, as I told you that here the system will, the algorithm will try to keep the system in the safe state. So they will partially allocate some of the resource, some of the instance to the processes, and some of them they will keep with their self. And as I told you before that, the processes will wait for some amount of time. When they receive the complete or maximum claim resources, okay? So, okay, one thing is clear, we find the free resources. Now I'm going to find the need resources. So this is the available resources. How much resources are required by the processes more? So for this purpose, I already write the formula that need equal to maximum minus allocation. Okay. So guys, how much is this was the maximum claim. How much is allocated from, okay, let me before this, it will be good if I write A, B in the front. A, B, C. A, B, C. A, B, C. Okay. So P0 claimed for 753 instance of resource A, B, C. How much is allocated? 0 from A, 1 from B, 0 from C. So it means how much is need? It's very simple. Let me use the pen. Minus this 0 from this 7. Minus this 1 from this 5. And minus this 0 from this 3. Okay. So after doing this, we will easily understand that the P0 still needs 7 instances of resource A and 4 instances of resource B. And how much instance of resource C? 3 instances. It is clear, dear students?
Yes, sir.
Okay, good. Okay, P1. Now P1 was 3, 3, 2, and 2. This is the maximum claim. How much is allocated? 2, 0, and 0. Okay. So dear students, after P0 we have P1. P1 claim for 3, 2, 2 and allocated 2, 0, 0. So how much is need more? Okay. So 2 minus 3 is equal to, no, I had a mistake. It's absolutely right. Okay. So
It's okay, sir. 1.
yeah, 1. Yeah, okay. 2 minus 3 is equal to 1. 0 minus 2 is equal to 2. And 0 minus 2 is equal to 2. So this much is more need. For the P2, it demand for how much? For the 9, 0, 2. Okay. How much is allocated? 3, 0, 2. Very good. And how much is need? 3 minus 9 is equal to 6. 0 minus 0 is equal to 0. 2 minus 2 is equal to 0 for P3. Okay, guys, P3 is demanding 2 instances of, this is the maximum claim, okay? How much is allocated? Allocated is, it's P3, na? Yeah, 2, 1, 1. So how much is need more? 2 minus 2 is equal to 0. 1 minus 2 is equal to 1. 1 minus 2 is equal to 1. For the last process, which is P4, P4 claim for how much? 4, 3, 3. And allocated is how much? 0. Remember, I am taking these values from this table, okay? There is the maximum claim and there is the allocated. So I'm not bringing these value from somewhere else, okay? Don't be confused, dear students. Okay. So allocated is how much? 0, 0, 2. How much is need more? 0 minus 4 is equal to 4. It means still it's need 4 instances because nothing is allocated. 0 minus 3 is equal to what? 3 because nothing is allocated. But here in the C instance, in the C resource, 3 instances were claimed. 2 is allocated. So it means 2 minus 3 is equal to 1. 1 is required more. So dear students, this is our required amount of resources, okay? And I have to write them here in this table. And you, in the exam, your first job will be to find the free amount of, the available amount of resources, the need amount of resource. First job will be to find the available, second job will be to find the need, and third job will be to decide that which process is in a safe state or which process is in a unsafe state, okay? So now let's complete our second task. 3, 4, 3, okay? Dear students, follow me. If I do any mistake, inform me, okay? Here 6, 0, 0. For the P3, 0, 1, 1, okay, 1. For the P4, which is the last one, 4, 3, 1. Okay, guys? Very good, dear students. Okay, so 2 jobs are successfully done. Now come back to the slide. Come back to the slide and we will try to run the safety algorithm on the same example. Dear students, this algorithm say that you will have 2 things here. You know that N is the number of processes where M is the number of resources, okay? Work and finish be vector of M and N. Work mean available resources. Remember, work mean what? Available resources. Where available resources mean what? M. Finish mean I. Finish can be what? I mean what? Any running process. Do you remember I told you any running process will be what? I. Okay. So in this algorithm, these two vectors will be used. I can be considered finished when it got their complete resources. Like for example, when the resources are the need resources are smaller or equal to work. Work mean what? Available resource. The needed amount of resource of a PI is equal or less than work. Then the PI will got their full resources and PI will become what? Terminated. And terminated PI mean finish PI, okay? Remember, F mean finish. Finish mean terminated PI, okay? But when this case is not true, in cases like this, that need is greater than or equal to work, okay? So most of this not equal. So the need is greater or not equal to work, then it means what? The I is false. The I is what? I is false. It means that the finish condition become false. And when the need is less than or equal to work, that the finish condition will become true. And dear students, we will try to find the true. If every single process become true, it means our system will be not in the safe state. But when the process or the F become false, it means our system will be in the unsafe state and the process is in a deadlock situation, okay? So don't be confused. Let me repeat this again. We have two cases. In one case, the needed resources will be greater than work. In such case, the process I will be finish false. Okay, if this condition become true, then what will happen? Then the finish I will become true. Okay, and so when the finish I become true, then dear students, the work, the available resources and the allocated resources to that processes we will combine them and the system will got more resources. Okay, and the system will got more resources. Okay, is it clear? Hello? Okay, hope it's clear.
Yes, sir. Yes, sir.
Okay. So come back to the example. Don't worry. Here you will understand this more, okay? But let me copy that. Copy these conditions. Need is this. So okay, I'm going to write them here. When this condition becomes true, then what will happen?
And I will be true.
Yes, I will be true. And their resources must be resubmitted to the system, and the system will have more free resources. Okay, but this is condition one, and the condition two is that when this is else will be okay. Yeah, when this is condition 2, when need is greater than work, then what will happen? Then the I will become false. It means the finish will be false. Okay, based on this, now come to the our example.
The need is greater or equal to worker.
Yeah, yeah.
conditions.
Okay, yeah. But let me make it simple, okay? Focus, dear students. Right now, available resources are three. The A in 3 instances are free. With the B resource, 3 instances are free. With the C resource, 2 instances are free. Good. And now you can see the need amount of resources. So can this system satisfy which process request? 7, 4, 3? No, it is what? It is greater than the work or available resources. 1, 2, 2. Yeah, this is makes sense. 0, 6, 0, 0. No, 6 is greater than 3. 0, 1, 1. This is also makes sense. The 4, 3, 1, 1. This is greater. So it means you have two options to allocate these resources to process 1, or you can also allocate these resources to process 3. So the system will check the best option here. And the best option is, I think, the P3. Because if we give some of the resources from this available resources to P3, still our system will have some resources. But if we give the resources to this P1, the C instance will become 0, okay, at the runtime. So it means comparatively, this P3 is good. So let's assign the resource to P3. So dear students, according to this, these conditions become true for the P3. Need is less than work. Finish the PI will become true. Okay, let's run right here the PI. PI. But this PI is P3. Okay, so P3 is equal to finish. Okay, finish is equal to true for what? For which process? For P3. Good. Once this has become true, now I have to apply the second condition. This, and according to this, work plus allocation. So the allocation must be added to what? To the work. Work is the free available resources. Allocation is how much? 2, 1, 1. Okay. So you can easily say, dear students, 3 plus 2 is equal to how much? Is equal to 5. And the 1 plus 3 is equal to 4. And this 1 plus this 2 is equal to 3. Now the system have this much resources. I have to add them here. 5, 4, 3. Okay, guys. See, work equal to work plus allocation. So allocation, this was the allocated values. This allocated value is added with the work or available resources. Now the system have more resources and the system can satisfy more processes. Okay, guys. Let's see. Yeah, let's finish P1. Now it's good time to finish P1. P1. Okay. And add the resources of P1 with the available. The system have how many resources? 5, 4, and 3. Okay. This is the available resources with the system. How much was allocated? Plus 2, 0, and 0. 2, 0, 0 come from where? From this, from here. Okay. So 7, 7, 4, and 3. Let me write this here. 7 and 4 and 3. Done? Okay, guys, let's find another process to make that true. So successfully, two processes are done. Those processes are P3 and P1. Okay. Now the system has 743 instances. Can it satisfy the P2? Yes, of course. Can it satisfy the P4? Of course. Even it can satisfy the P1, so P0. So it means now there is no problem. There is no problem. And we can true all the processes. But let me true the last one, which is P4. The order can be different here. Okay. If someone solve this with the order which I'm selecting, no problem. If you select here P0 or P2, it's totally okay. Okay. P4. Now I have to add these resources with this available resource. Available is 700. So 0, 0, 2 is equal to how much? Is equal to 5, 4, and 7. The system have 7 and 4 and 5 instances. Let me finish the process number 2. Yeah, process number 2600 P2. Okay. So P2 allocated resources are how much? 302. So with this 745. Okay, 745. Remember, this is not 745. Okay. Okay, the P2 was, yes, 302. So equal to 10, equal to 4, equal to 7. So now I have to write them 10, 4, and 7. Good. And finally, one last process, which is P0. P0. So it's also become true. And students, when it's become true, I have to allocate their resources to these resources. So my current available work is 10, 4, 7. So 10 plus 0, 10 plus 1, 4 plus 1, 7 plus 0 is equal to how much? 10, 5, and this is 7. Okay. So dear students, here I should write 10, 5, and 7. So as you saw, our system is not in a deadlock situation. Our system successfully assigned all the resources to the running processes. So dear students, at the T1, the system condition was this. Sorry, T1 or T0, okay? At the T2, the system condition was that. In the T3, the system condition was this. So I have how many T's? I have 5 T's, okay? I think 6 T's, okay? T mean time, okay? That in these 6 times, the system got multiple situation, and finally all the processes are become true. They finish become true, and the system got back their resources. How much resources were there? 10, 5, 7. So 10, 5, 7 is here. So dear students, you can see the safety algorithm is successfully applied, and our system have not faced any deadlock. Okay.